So, hello everyone, welcome back to my YouTube channel IIT and Study Point. I am Shivasankar Hasta, a third year undergraduate student in the Department of Electrical Engineering at IIT Kharagpur. Okay, so in this video I will be telling you an excellent trick to solve any kind of complicated fully blocked problem. Okay, so here you can see a very complicated fully blocked problem. Okay, and this is the mass m1 and this is another mass m2. Okay, we are asked to find out the relationship between the acceleration of these two blocks. Okay, that means m1 and m2. Okay, that means we have to find out the relationship between a1 and a2. Okay, so this type of complicated pulley block problems can be simplified by applying a super trick. So let's see what is that trick. Okay, so in order to solve any kind of complicated pulley block problem, so we have to keep in our mind these three important concepts. Okay, let's see the concepts. What are the points that we have to keep in our mind while solving any kind of pulley block problem? Okay, so the concept number one is same string implies that same tension. Okay, so for a massless and frictionless string, same string means same tension everywhere. Okay, this is the concept number one you have to keep in your mind. Okay, this is the concept number two. Concept number two says that net force on the massless pulley equals to 0. Okay, if your pulley is massless, then net force on that pulley should be equal to 0. Okay, so let's say this is our pulley and let's say these are the two tension in upward direction. So there should be a downward direction 2T tension. Okay, because the net force on any kind of massless pulley should be 0. Okay, so this is the concept number two, and here it is the concept number three, that is the virtual work concept. Okay, that is the summation of tension dot x equal to 0 or summation of t dot v equal to 0 or summation of t dot a equals to 0. Okay, so these are the three very important concepts that you have to keep in your mind while solving any kind of pulley block problem. Okay, so let's apply these three concepts to solve this problem. Okay, so as you can see, let's apply first concept number one. Okay, so concept number one says same string means same tension. Okay, so as you can see from this to this, okay, from here to here, this is only one string. Okay, this is same string. Okay, so from the concept number one, same string means same tension, so the tension here will be T in upward direction, here in this string will be in upward direction. Okay, from because the tension is always from the away from the end point. Okay, end point or tied points. Okay, so tension will be T here, tension here also will be T because this is the same string. Okay, this is the concept number one. Again here also tension will be T because this is the same string, so tension everywhere here will be how much, this will be T. Okay, here also will be T. Okay, and the direction of tension is always from the away from the end point. Okay, this you have to keep in your mind. Okay, so again next apply the concept number two, that net force on the massless pulley should be 0. so because in this pulley net force is 2T in upward direction, so here it will be in 2T in downward direction. Again this is the same string, so here the tension will be 2T. Okay, similarly for this pulley also net force is in upward direction 2T, so this should be 2T and here also will be 2T. Okay, for this pulley also, here is a force T in upward direction, here is another force T in the upward direction, so 2T force is in upward direction, but net force on the massless pulley should be 0, so this force should be 2T. From this is another string, same string means same tension, so tension here will be 2T. Okay, similarly for this string the T is in the upward direction. Okay, so let's apply the concept number three. Concept number three says summation of tension dot acceleration should be equal to 0. Okay, so as you can see, if you see the this mass m1, okay, in m1 there is 2t plus 2t plus 2t, that means 60 force is in upward direction and acceleration is in downward direction. Okay, for m1 this is okay, and for m2 body tension is in upward direction and acceleration is also in upward direction. Okay, so let's apply this T dot A equals to 0. If we apply T dot A for this, as you can see, tension is in upward direction and acceleration is in downward direction. Okay, so angle between the T vector and A vector is 180 degrees. So T dot A will be how much? It will be minus 60 into A1. Okay, minus, since the angle is 180 degree. Okay, so cos 180 degree will be minus 1. Okay, for this mass the tension is in upward direction and acceleration is also in upward direction. Okay, so the dot product will be how much? Plus T into A2 equal to 0. Okay, you have to apply this formula only for these blocks. Okay, because the net work done on this pulley is 0. Okay, so from that what will happen? T times of AT equals to 6T A1. Okay, from this TT get cancelled out, so A2 will be how much? 6 times of A1. Okay, so this is the relationship between the acceleration of these two blocks. Okay, so you can apply the same concept for any kind of complicated Pulley block problem. Okay, so thank you.